Here we're given two piecewise defined functions, f and g, and then we're also given h, which is just your standard linear function, x minus 2. And we're asked to determine the following function values, compositions, and also to graph each function. So there's a lot going on in this particular problem. So let's go ahead and get started with this. First, let's talk about A for evaluating each of these guys. So f at each of these values, so f at -1, 0, 1, 2, 3, and 4. Okay, how do we do this? Well, what we do is we take a look up here at the original function, and we say, okay, which intervals are we concerned with? Well, there's one interval where the function's equal to 3, and that interval is all x's that are strictly less than 1. Then there's another interval where we use the function x minus 2, and that's for every x value between and including 1, but not including 3, so everything in here. And then we take a height value of 1 whenever we are 3 or more. So what we have to do is we have to look at each of the guys in here in the domain and say which interval do they fall on. Once we find the interval they fall on, we know which one of these to plug them into. So -1. Well, -1 clearly falls on this interval, so we plug it into here, but there's nowhere to plug it in, so we just have an output value of 3. In fact, anything that's less than 1 that we plug in will have an output value of 3, so does 0. Now 1 occurs at a boundary spot. So since 1 occurs at a boundary spot, we have to see which one do we use, the first one or the second one. Well, clearly we use the second one because this guy's got a filled-in circle. So we take the value 1 and we plug it into this function, so we get 1 minus 2, which is -1. Now let's look at 2. Well, 2 falls on this interval. So when we take 2, we plug it into this function here, and we get 0 out. Now we look at 3. Well, 3 is a boundary point, so it falls here and here, but this guy's an open circle, so we don't use this one. We use this bottom one. So when we take 3, there's nowhere to plug it in, so our output is 1. And the same thing with 4, there's nowhere to plug it in, so our output value is 1. These are your answers for the different f values. Now let's go ahead and take a look at the g values. You can see this takes a little bit of time, especially when you're trying to explain it. So g is a little bit better because g has only got 2 functions here to look at. I'm not going to go through quite as detailed as I did the last time, but I'll say that our boundary value is 0, so anything less than 0 gets this first equation up here. I know it's hard to see this first guy right here, and anything that's 0 or greater gets this greatest integer function here. So it's going to go very quick because everything from here down falls under the second one. So those are all just going to give you the integer values. The first one, though, that's when I got to take the -1 and plug it in. So it's going to be -1 squared, which is 1, minus 3, which is -2. And then, of course, we've got h. H is a pretty easy one to work with as well. So for each of these guys, we've got to plug them in to this function right up here. And so when I plug in -1, I get -3 out, 0 I get -2, 1 I get -1, 0, 1, and 2. Okay, next we have to evaluate the composition of a couple of these functions. So let's take a look at this first one, f of g of 1. So what that means is we have to find g of 1 first. Okay, so let's find g of 1. Here it is, that's 1. Now we have to find f at 1. So f at 1 is -1. So this first answer, f of g of 1, that's equal to -1. Now let's take a look at the second one. We need to first find h at 1. So h at 1, I'm going to go ahead and delete these so it's clear again. H at 1 is -1, but now I need to go ahead and take -1 and plug it into g. So g at -1 is -2. So that means that g of h of 1 is -2. Whoops, I didn't want to have that disappear, so let's go ahead and bring that back. Okay, the last one, g at 3.5. So this is inside here, so I take 3.5 and I plug it in. Now 3.5 is not down here, so I actually have to use a function. So 3.5 plugged into g. This says round left, so this goes to 3. So g of 3.5 is 3. So what we need is, what is f at 3? And f at 3 is 1. Now we need to graph each of the functions. Okay. So let me erase this over here. And we're going to have to graph all the functions over the same interval. So I'm actually going to graph them all on the same line, I think. We'll see how the first one goes, see how much room I've got. Okay, so here's -5. Here's 5. Okay. So let's graph f first. When it's less, when the function is less than -1, it takes on a height value of 3. So when it's less than -1, it takes on a height value of 3, so not including -1. But on that side, it's got a height value of 3. Now, when it's between 1 and 3, including 1, not including 3, it takes on x minus 2. So it's going to have a y-intercept of -2. Okay, so y-intercept of -2. Now our next division line here is 3. And so it's got a slope of 1. So it looks like it'll go like this. And an open circle right here. So if I take 3 and I plug it in, I get positive 1 out, right? If I take 3 and I plug it in, I get 1 out. But we don't include that because this is not underlined right here. So I'm going to get rid of this, just so it's a little bit clearer over there. And now, over here, the last thing is when it's 3 or greater, it's at a height value of 1. So this gets filled in. And it looks like that. It's always at a height value of 1. Okay, so that's our graph of f. Now let's take a look at our graph of g. Well, g takes on, we'll do this guy in blue, okay? G takes on, so 0 is our division line. Okay, I'm not going to draw it in there because we already have the axis. And when it's less than that, it takes on x squared minus 3. So that's down 3. Okay, I'm going to put an open circle there. And then it's going to be a parabola, right? So if we start plugging in some values, like let's say we plug in -1, I get -2 out. And if we plug in -2, I get 1 out. Okay, so on and so forth. So the blue graph is the graph of g. And it looks something like that on the left side. Now on the right side, it takes on this greatest integer function. Hopefully you looked at the function in the book, and then you saw what the greatest integer function looks like graphed out. So here's what it's going to look like on the positive side. Anything between 0 and 1, not including 1, will have a height value of 0. at 1, when I plug 1 into here, I get 1 out. And if I plug anything between 1 and 2, like 1.5, I get a height of 1 out. And then at 2, I get a height. If I plug 2 into this function, I get 2 out. If I plug in 2.1, I get 2 out. If I plug in 2.2, I get 2 out. 2.3, 2.4, 2.5. They all give me 2 out, all the way up until 3. Okay, and then, of course, this step function, because it looks like steps, continues. So this blue one is g. And then the last function is h, and that one's a pretty easy one to do. It's got a slope of 1 and an intercept of -2, so it starts here. It's got a slope of 1. It comes up just like this, so on and so forth. And of course, it extends down this way as well. So the green one is the function h.